Good evening, friends. Today, before loading the video, a bhajan, Krishna bhajan on Radha Krishna, will be played in the Casio. Now it is evening, better to pray to God. So I am playing it, okay? But I am not singer, so pardon me, okay? Momo antaro mondire jago jago Madhav Krishna Gopal jago Krishna Gopal Momo antaro mondire jago jago Madhav Krishna Gopal jago Madhav Krishna নবরুণ সম যাহা গেছে প্রাণ নবরুণ সম যাহা গেছে প্রাণ জাগো তুমি যা সুন্দর গিরি নয়নে ঘন ব্যথারি বাঁধন নয়নে ঘন ব্যথারি বাঁধন জাগো জাগো তুমি কিশোর voice is not rising. Okay. নয়ন নয়নে গণান ব্যথারি বাঁধন নয়নে গণান ব্যথারি বাঁধন জাগো জাগো তুমি কিশোর শ্যাম শ্রী রাধার প্রিয়তম জাগো হৃদয়ে মম শ্রী রাধার প্রিয়তম জাগো হৃদয়ে মম জাগো তুমি ব্রজের So now better to play in music so that it is sweet to hear. My voice is not clear, so I'll play the Casio which will be sweet to hear. So many mistakes. Pardon me. Okay. Friends, good evening. So there is a query why z is multiplied for with 0. How much? 281. 285. How much it is? 0.2185. So it is from the equation of the diagram. If you solve the two triangles, then it will come out. I have told that I will clear it. So, and in Ashida manual also you will get it. You see, in the parallelogram what we have done, we have taken a plus r direction, a minus r direction, one RXM or reactance direction, and একটা backward reactance direction. Means x positive, x negative, y positive, y negative. Our impedance is calculated by how it is calculated by resistance and reactance. Reactance is the combination of inductance and capacitance. So here we have given the forward reactance is called, the impedance is divided into two parts. One is sine component and another is cos component. We know any force can be divided into two parts. The angle formed is called cos component, and opposite it, the direction in the y-axis, it is called sine component. So here the parallelogram is taken. We will calculate the value and put it. Here Z is the impedance, X is the reactance, and R is the resistance. But forward resistance is somewhat low than resistance. So it is RF, forward resistance. Forward resistance is equal to backward resistance. Forward resistance is equal to backward resistance. Now you see here that red triangle. Here in the red triangle, X divided by AB, X divided by is equal to tan 70 degree. We know delay characteristics angle is 70 degree. So X is equal to how much? X is equal to AB tan 70 degree. AB tan 70 degree. Similarly, you take the bigger triangle. Here is also X common. So X matlab perpendicular divided by hypotenuse Z. X by Z is equal to how much? Sine 36.9 degree. 36.9. From here, if you equalize the two, both are X, then AB is coming out how much? 0.2185 into Z. 0.2185 into Z. So in this way, they have calculated it, the forward resistance, and from that backward resistance. Clear? Okay, friends. Next importance in induction substation is the polarity of current transformer. Power transformer, it is marked, but you need testing. I'll show you that. I have already shown you the polarity test. The transformer you can also test with the DC, but AC test is also there. Later I will see you the AC test. In the DC test, you have to find out the polarity for CT S1 and S2. So in the previous slide, I have told you how to connect the CT secondary. It will be in series circuit, series connection, because current is flowing in series. not in parallel. So connection will be in series. Both the secondary coil will be connected in series. But if you see in the field, S1 is connected after the relay with the S2, but it is in electromechanical relay. That problem has worked on in the microprocessor relay. Simply you put the secondary to the relay. So that is not. But if you want to know the basic, then you have to think in 130 kV from one phase one current is coming. That means the direction of current is power transformer side. But when it is returning, it is leaving power transformer towards the grid. So the direction of the current is reversed in two phase. So which we have checked in the DC testing S1 S2, actually which you connect in the incoming phase where the current is coming and going to the power transformer, there the polarity will be same S1 and S2. But when the current is reversed in the other phase, it will be altered. It will be reversed, not altered, reversed. So in the electromechanical relay, we are connecting S1, then relay, then again S1. But it is not parallel. It is in series. It is not in parallel. It is in series. The polarity depends on the current in the primary, direction of the current of the primary of the CT. According to this, here S1 and S1 is connected, but one S1 is actually S1 marked because we are testing with DC in the same manner. So same S1 is coming, but in the field, when you are connecting with the power transformer circuit 132 kV side, one direction is reversed. So we are connecting S1 with S1 and S2 with S2. Okay, but actually in the returning path it will be reversed. Current is reversed, then S1 S2 will be reversed. It is in 132 kV side and in 25 kV side. That is also the same theory. One end current is going to the OHE and returning it is going to the transformer. So direction is reversed both the cases. Again here is also in 25 kV side, but connecting S1 to S1. I think it is clear to you. But most important is differential relay. With the bushing CT we are connecting it, and its polarity is given. So you must connect in this way that the relay should not get additive current. It is differential. It will change the difference of the current. And the current will be opposite. So if you connect it and after actually immediately the CB has tripped, that means your connection is reversed. You need to reverse it again. This is the system, but you can do it properly if you check the polarity. If you check the polarity, differential relay also in the microprocessor relay, simply you put the connection. Okay, so the basic you can know better in electromechanical relay, but it is not required in the microprocessor relay, but your knowledge will be incomplete. You will know in the dark why it is happening. So try to understand it. Then your lightning arrestor. Lightning arrestor, it is connected to one end is phase and another is through the bond to the earth. Earth is earthing mesh, and a separate earth electrode is also used. For each lightning arrestor, you have to use separate earth electrode, earth cone. Don't forget it, okay? Each lightning arrestor needs separate earth cone. That is lightning arrestor. Then system earthing. System earthing means we are earthing one leg of the power transformer, one on the secondary side, one end of the CTPT, to the earth. Why? Why you are doing it? It is called system earthing. It restricts the voltage rise of the phase. Voltage rise of the phase. That means one end, if you connect to 0, then other end will be as per your potential difference. Our potential difference is 25. If you one end keep at 0, one end is earth of partners, then other end will be around 25. But if you don't earth it, then it may be that phase is 35 kV and your other end is 10 kV. That is also 25 kV difference. This is potential difference is 25 kV. So we are keeping one end at 0 in potential transformer, in current transformer, in auxiliary transformer. All we are doing it so that its insulation will be intact. If you control the voltage, it is called stabilizing effect. It is called stabilizing effect. Like stabilizer, it is controlling the voltage. If you lay at one end of this winding. Next is it is giving another facility also. What is that facility for power transformer? Your phase is going to OHE and other end leg is earth. Now when OHE will fall on the earth, then earth to earth will be connected. Earth is a good conductor, I have already told. So what is the facility of the earthing of the power transformer? It can create earth fall during failure. If OHE falls on ground or insulator broken or anything damage causing close contact with earth, then it will trip the circuit breaker. It is possible due to the earthing of one leg of the power transformer. So this is the facility of the earthing. And you know, from the ground level 600 millimeter below, we are creating an earthing mesh. Why this is earthing mesh? Earthing mesh is when there is a fault near to the TSS, the return current is so huge amount of return current, fault current is flowing. If your earthing is not proper, then this will affect the surface of the TSS ground, TSS yard. Then in between your two steps, the voltage will be severe and you will get shock. Simply in between your two steps, two foot step, you will get shock. And if you touch any metallic parts from the earth to the mast, you will get shock. It is called touch distance and step distance. So we are doing earthing to reduce the step voltage and earth potential also. Step voltage and touch voltage. It is called step voltage and touch voltage within safe limits, so that we cannot get any electric shock. It is very important. In field also, if you don't earth the mast with the structure bond and your insulator has broken, then the current will leave the surface due to short circuit. When the insulator will break, it will come to the mast, and the foundation is not a good conductor, foundation concrete. So the charge will come out and try to come out in the surface, and person may get shock. So earthing has tremendous importance, not tremendous, absolute importance. These only save men and material and animals. So keep in view about the earthing. It is the first and foremost important. Then is your working. You have to earth the site, because after making dead the OHE also, there is magnetic and induction effect of the side line, another line which is live, it will come and it is sufficient to give electric shocks for a fatal shock. So next importance is discharge rod, earthing rod. You have to protect from two ends, and the distance they have told 100 meter at site. 100-meter distance, within 100-meter distance you have to put two discharge rod. Next is the sectioning point. Each sectioning point, if you don't earth separately by two discharge rod each section, two discharge rod in each section, you may get shock. Sometimes what we are doing, suppose one section insulator, what we have done, and another section has having isolator switch. So what you have done, you have at the other side of the section insulator, you have thought that the isolator is closed, but during maintenance you have opened the isolator, so other side will not get the earthing. Discharge rod is not provided that end, and the man working there will get shock. The man working there will get shock. So sectioning point is a dangerous thing. Keep alert that each section to be protected with the two discharger. Then your neutral section. Very careful in the neutral section. Also you have to take as live. Neutral section you have to take as live. Okay. So today this is sufficient. Next I will tell you again. Okay.